Hey guys, today I'll be showing you how to make this simple platformer in Godot. So let's get started. First thing you're going to want to do is to install the Godot engine if you don't have it installed already. I'll have a link to it in the description below. And after installing, open it up and you'll probably be met with a screen like this. We're going to want to create a new project, and here you'll select where you want this project to be saved. So for me, I'll just select my Godot folder and create a new project called Demo Platformer. Select current folder, project name is also Demo Platformer, and we'll create it. And given this new project, we'll be met with this empty screen with no assets or anything. So I've provided a link in the description where you can find the assets that we'll be using for this project. Here I have it inside of this folder called platformer assets, and what we're going to want to do in order to add this or add these to our game is to copy, or I guess cut, and then find wherever we created our project. So for me it was in Godot tutorials and demo platformer, and just paste it here. And then now if we go back to the editor, we should find our assets here. So the first thing we're going to want to do is to create our player object, and our player object is going to be type kinematic body 2D. So what I did right there was click this plus button, and then in the search bar I'm going to type in kinematic body, or and then you'll see here it comes up kinematic body 2D. Double click it to add it. If you hover this yellow triangle, it'll say that given being that this is a kinematic body 2D, it has to have a collision. So we'll add that too. So search up collision, and then select collision shape 2D. And this collision also needs a shape. So on this right hand side in the inspector, in shape, we'll select capsule because we want our player to be a capsule shape. And then now just rename kinematic body 2D to player, and then Control S to save. Now that we have a player and a collision, we're going to want to add some graphics so that you can actually see your player in the game. So to do that, we add another node, and the one we're going to be adding this time is sprite. And for sprite, sprite takes in a texture, so in our sprites folder there should be a player.png. Just drag it over here into the textures, and you'll see we have a little player. You might notice it's a bit blurry. That's because by default when importing images and such into Godot, it'll be imported with a filter on, which kind of like tries to soften any images you have. But when working with pixel art, we kind of want to preserve that jagged edge. So in order to fix this, we're going to want to click on player.png, and then right next to scene there's a tab called import. And then if we scroll down a bit under flags, there should be filter, and click off, and then re-import. And then now you see pixel perfect pixel art. And we're going to want to repeat this for all of the images we've imported, so coin, tile 1, tile 2, and tile 3, so that when we use them in the future they won't be blurry like the player was. Now that we've done that, you saw I kind of just reshaped the collision to fit the player better. You can do that by just dragging these orange circles on the collision, and I guess a better way to do it might be to, on this top bar over here, these three dots, click use pixel snap, so that you're able to align the collision up with the edges of the player, as you see right here. And being that our player is kind of a ghost, it's okay if some of the collision doesn't match up with the exact bottom of the sprite, because it'll give kind of the effect that he's floating. So after we've made these changes, we're going to want to save. And then now we have a player, we have collision, and we have the sprite. Next we're going to want to kind of add the ability to control the player, because now if we go up to the top right, play this scene, you'll see if you look really closely on the top left, there's a kind of a white pixel. That's our player, and moving the arrow keys or pressing on the arrow keys does absolutely nothing. So we're going to want to implement some movement, and to do that we'll do it through a script. So first thing we're going to want to do to add a script is to click on the player, kinematic body 2D, and then right here there's a button that's to attach a new script to the selected node. So we're going to click it, and it's fine being called player.gd by default, and we're going to click create. And here's our script. This is really where the brains of the operation is going to lie, where we define movement and other things, maybe like fireballs or something. But for this tutorial, we're going to be focusing on movement and coin collection. So let's think about what we want our player to be able to do. We want it to be able to move, and that's pretty much it for now, because we'll just focus on one thing at a time. So for movement, we're going to want to define a variable called speed. So this is going to be the speed that the player moves at, and for now we can just set it to 100. And then we're also going to want to have something to store the velocity of the player, as in like what direction they're moving, what direction they're moving, up, down, left, right, and such. And we assign this by default a vector 2. Next, what we're going to want to do is you see over here in the auto-generated script, there's a func process delta. Just to demonstrate, you don't have to do this, but if inside of this process delta, I print A, you'll see when I click play scene, it'll print A every single frame. So basically what this process is doing is it's running whatever's inside of here every single tick it can. So this is basically where we're going to put our movement data and stuff, because we want that we want those things to be calculated every single frame. But for our purposes, we won't actually be using the process function. There's actually a separate function called func physics process, and this physics process is different from the normal process in that this physics process tries to align every single call of this, or from what I understand, it tries to align every call of this function to the frame rate of the game. Well, this one tries to call it as fast as possible. So as soon as the previous iteration finishes, it tries to call it again. This one aligns it with the frame rate of the game, so that any physics bugs you might encounter using process, it'll be minimized when using physics process. So before we actually do any input, we're going to want to define what buttons we want to use to control the player. And in order to do that, we go to the top left, project, click on project, inside project settings, and you should see to the right of general input map. And you can see that there's some default key bindings that Godot provides in every default project, but for our purposes, we're going to want to define our own. So action up, just type up, and then click enter or the add button. And in this new event, click the plus symbol all the way to the right, add a key, and this key, I'm just going to press the up arrow. So after pressing the up arrow, click OK, and then now this up arrow event is bound to this action called up. And we're going to want to do this with all other directions, so up, down, left, and right. Now we have these key bindings. We can go back to our script. To actually get input, there's many ways to do this, but one way I like to do it is to use the input func input event function. This is called every time an event occurs, so let's say moving a mouse or pressing a button, every time something like that occurs, this will be called. So in order to actually use this, we're going to need to go into the ready function and then type in set process input, and then inside of this we say true to let the script know that we're going to be using the input process. And although physics process is set to true by default, I also like to put explicitly inside of the ready function that we're using it, so that it kind of like a reminder to me that we're using it. But anyways, inside of our input function, we're going to want to kind of parse the inputs of what the player is currently pressing down. So in order to do that, we're going to want to create additional variables up for the up direction, down, left, and right. We're going to set these as booleans because it's a button press, so it's going to be true when the up button is pressed, false when it's not pressed. So initialize them to false. And in this input event, we're going to add a bunch of if statements. So if event dot is action pressed, and then autofill, we can go down and find our up event. If action is pressed up, then we set up equal to true. Elif, so elif is kind of like else if, but yeah, when doing it in Godot, you need to type elif. Then elif event dot is action released. So if the up arrow is released, then we're going to want to set up to false. And we're going to want to do the same thing for down, left, and right. So I'll just copy and paste all this code. And kind of adding spaces to make it look a bit neater. We'll just change this to down and copy and paste it. And save. Just a quick note, this isn't the only way to do inputs. This is just the way that I like doing them. But yeah, with these inputs now set, we can go into our physics process and kind of like do a test print. So let's try up. So if all works correctly when we test play this scene, pressing up will print, or when we press up, this false will become true. And yep, good. So now for actually moving the player. So let's think about what we want to happen when we press up, down, left, and right. So given that we're working on a platformer, the down button doesn't actually do anything, because up is jump, down, if you think about it, in the platformers you've played, doesn't really serve a purpose because the player is always being pushed down by gravity. But in any case, we've added it here. So if you wanted to add like a sliding mechanic when you press down, it's here available for you. But yeah, so we're gonna want to find out whether the player is moving left or right first. So we're going to create a variable called hdir, which stands for horizontal direction, and the value of this is going to be int left, actually int left minus int right. And what this means is we're taking left, which is a boolean, and casting it to an integer. So a boolean is 1 when it's true and 0 when it's false. So thinking about it, if left is 1, or if left is pressed, then int left will be 1, and then hdir will be 1, but that's only if right is not being pressed. If right is also being pressed, so that means left and right are being pressed simultaneously, left will be 1 and right is also equal to 1. So then 1 minus 1 is equal to 0, so our net horizontal direction will be 0. So this kind of calculates, based on what buttons you're pressing, which direction you should be moving in. And just for testing, we're going to want to set velocity.x equal to hdir times our speed variable that we set up here. And to actually get movement from the player, we're going to want to call the function move and slide. And in this move and slide, we're just going to pass our velocity. And save, and try running this scene. And if all worked correctly, when you press left, you should move left, and if you press right, you should move right. And of course, I messed up. It should actually be right on this side, and left on this side. So, yeah, because if you think about it, right is moving in the positive direction and left is moving in the negative direction. So when pressing left, hdir should be -1. When pressing right, it should be +1. So now when we run it, pressing right should actually move you right, and pressing left should actually move you left. You should see your character move all the way in the top little corner of your scene. That's good and all, but it's kind of pointless just having a little character moving on the top left without being able to even see what's happening. So to solve that, we can go to our player, click plus, and add a camera. And this camera will kind of follow the player around. If you see this purple border, this is the size of the camera. And if we play it right now, nothing will happen, because in order for the camera to actually function, we have to set current to on so that the engine knows that this is the camera we want to follow. And then now, playing it, you should see our character is now in the middle of the screen, though quite small, and pressing left and right, although it seems to do nothing, actually still moves the player, but it seems to do nothing because the camera is moving along with the player. But yeah, so to make the player kind of bigger, I guess, in the context of the camera, we can set the zoom to 0.5, and now the player will be a bit larger. I think we could even set it to 0.25. Yeah, and then now clicking play, they should fill up a larger space on the screen. And that's great. Now you see we're moving left and right, but we kind of want the player to indicate that we're either moving left or right, because even when we're moving to the left, the player is still facing towards the right. And to do this, we'll be working with sprite scale. So if you come over here, you can kind of like play around with sprite scale, try setting x to -1 or setting it back to 1. That'll change the direction of the sprite. And to take advantage of this fact, we go to physics process, and then if hdir doesn't equal to 0, we don't want to change the direction that the player is facing if the horizontal direction is 0. So if it's not 0, then we're going to want to access the sprite and access the scale property, and then we're going to set the x scale equal to horizontal direction. And saving it now and playing the scene, we should see that the player turns along with the direction that they are moving in. Awesome. So now we just have a player moving along a horizontal axis. Kind of pointless also because we can't really see them moving in relation to anything, so on our screen it kind of looks like they're stationary. So to solve this, we'll go to the top left, create a new scene. And this scene, the root node is just going to be a 2D scene, so click this button, and we're going to name it to world. This is going to be the world where the player is in, and where the actual level will be. And save this scene, save it as world.t scene. And then in order to actually move this player into the world, we click this instance button, and we can just click on player, and he is now in the world. And inside of this world, we can just temporarily, to actually see that the player is moving, we add a sprite. So yeah, nope, the sprite is alright. So sprite, first we're going to want to set a texture for it, and then we drag it around. So this is just the icon.png, just here for testing purposes. If we put it here and then we play the scene, we see that the player, we actually are able to see that the player is moving in relation to this new sprite that we put down. Okay, so we have the player moving on a horizontal axis. Now we're going to want to add jumping and stuff, and also falling. In order to do that, we're going to go back to our player scene and open the script up again. We're going to want an additional variable and call this gravity. For now we can set it to 3 or 10. Yeah, set it to 10, and then we're going to want also a max gravity, so that gravity doesn't go to infinity. And this can be set to 1000. Alright, so what we're going to want to do now is, now that we have gravity and max gravity, we're going to want to, on every physics process, apply this gravity to the player. So in order to do that, we just do velocity.y plus equals gravity. And then to cap the gravity so it doesn't go beyond 1000, kind of like terminal velocity, we go over here and velocity. Actually, I'll rename this to max fall. Terminal velocity. So yeah, it's their terminal velocity. They can't fall faster than that speed. So velocity.y equals the min between terminal velocity and the current velocity. So if it goes beyond terminal velocity, it's just bounded back to terminal velocity. And now if we go back to our world and add the sprite again to see movement, we see that our player is falling. Awesome. Yeah, so given that there's no other collision objects in the scene, our player just kind of falls into the void. So we're going to want to add a temporary collision just so we can play around. To do that, we create a static body 2D, and in the static body we add a collision shape 2D, and the collision shape 2D, we'll just set it to a rectangle shape, and then just drag the orange circle to create the floor. And collisions aren't actually visible in game, so for debug purposes we can go to the top left of the editor. Right next to project there's debug, and then there's visible collision shapes, and we can click check on that, and then now when we play the scene, you see we've fallen onto the static body and are now moving around on it. Pressing up doesn't do anything because we haven't implemented jumping yet, but we're going to do that now. So one more thing to take note is that I guess it'll be more easily visible if I duplicate the static body and kind of add a ledge. So we'll chill on this static body for a while, but then moving on to the next level, you see how quickly the player fell from there to there. That's because even when the player is on a static body, they're kind of accumulating gravity onto themselves until they reach terminal velocity. So in order to kind of counteract that, we're going to want to make sure that gravity is only being applied when the player is not on the, or is not colliding with the floor. And to do that, there is a function in Godot called is on floor. So as long as this is not true, so if the player is not on the floor, we denote not with the exclamation mark, then we increment velocity dot y. If you tried playing this scene right now, you'd notice that you'd still fall with incredible speed. That's because is on floor actually only works if we add one thing to move and slide. That is, we have to let the engine know which direction is the up direction, so that it knows kind of what direction, or what the floor is, like the floor normal, I guess, if you've taken physics. But yeah, so our normal is quite simple. Up is in the up direction, I guess, and in our case that is vector 2, 0, -1. And now if we were to play the scene, you'll notice that we fall less violently when moving from one ledge to the other. Alright, now for actually jumping. So jumping, we only want to be able to jump when the player is on the floor. So we're going to be using this function again, but we're also going to want to, in these variables, set a jump height variable. So jump height, and we can set it to, let's say, 300 to begin with. So yeah, if is on floor, so if the player is on the floor, if up, remember this up is the variable we've set for detecting whether this button is pressed. So if up, then we're going to want to just set our velocity to the negative of jump height. So make sure you have a negative before jump height, because in Godot, I guess moving upwards is actually moving in the negative direction, and moving downwards is positive. So yeah, now we can test our game by going to world and then pressing up. Now you see our player is able to jump, and I feel that the jump height is a bit too high, so I'll reduce it from 300 to maybe 200. And yeah, that's much better. Now, instead of just jumping around on these featureless static collision or static bodies, we're gonna want to create actual terrain with these tiles we've created. So in order to use these tiles, we're going to want to use what's known as a tile map. So Tilemap is a node in Godot that kind of lets you use a tile set to paint a map. And we haven't created a tile set yet, but we're going to do that right now. So in order to create a tile set to use with this tile map, I like to go to Scene, click New Scene, and then the root node is again a 2D scene, and rename this to Tile Set. And in Tile Set, we're going to want to add a child of a sprite, just a normal sprite, and this sprite we can rename it to Tile1. And Tile1, we're going to add a texture, and it's going to be this first tile. And since we want our tiles to have collision inside of the tile sprite, we're going to add a static body 2D, and as we know, static body 2Ds need a collision, so we add a collision shape 2D. And this collision shape 2D, we're just going to define its shape as a rectangle shape, and then make sure pixel snapping is on so that we can fit it perfectly to the edge of the sprite. Awesome. Now that we have our tile, we're going to want to keep the collisions in the same place so that when we drag it, we don't accidentally move it around. So to do that, just click on static body 2D and click this lock icon on the top, and collision shape 2D and this lock icon on the top. Now we can press Ctrl D to duplicate this tile we've already made. And once we do that, we can drag it out and press Ctrl D one more time for a third tile. And each of these tiles, we're just gonna change the sprite they have so that they have a varied appearance. And now that we have 3 tiles, we can convert this scene to a tile set by going to Scene, and then over here there's a Convert To, and then Convert To, inside here Tile Set, and you can just name this Tile Set and save. Going back to world, inside of our tile map, on the right in the inspector under square, there should be tile set. It's empty right now, but click the arrow next to it and load, and we should be able to open up the tile set we've just made. And now we can draw tiles wherever we want, but you might notice that the tiles are really small when compared to the grid, and that is because if we go back to tile map in the inspector, we'll see under cell that the size is currently set to 64 by 64, while our sprites are only 16 by 16. So to fix this, just change 64 to 16 on for both X and Y, and you'll see they line up perfectly. And then we can just select different tiles for I guess more interesting appearance of the terrain. And then now test playing the world. We see we're able to jump around on this tile map. And now that the terrain actually has graphics, we can go back to debug and then turn visible collision shapes off so that we have just our player jumping around on our tile map. You might notice that our background is kind of gray. If you want to change the color, there's many ways to do that, but I think the easiest for us right now is to go to project settings, and then in general, if you type search on the left, you should be able to just type in color, and then in under rendering environment default clear color, you just set it to black in our case, unless you want a different background color. But yeah, so now we have a black background with our tile map and player jumping around. Perfect. So the last thing we're going to be implementing today is a coin that the player can pick up. And to do that, we're just going to want to create a new scene. This one is not going to be a 2D scene, so we're going to want to press the plus button and change it to area 2D. And the area 2D, like the static body and kinematic body, needs a default collision shape, or it needs a collision shape childed to the node. So we're going to just click plus and collision shape. And in collision shape 2D, since our coin is kind of looking like a circle, we're going to want to set the collision to be a circle. And inside of area 2D, we also want to add a sprite so that the player can actually see where the coins are. And just drag the coin graphic into the textures of the sprite, and then now we can kind of drag the collision of the collision shape 2D to match up with the size of our coin. And we're going to rename this area 2D to coin, and then click Ctrl S for save. And yeah, now we can go back to our world and click on this button again, kind of chain, and instance a few coins into our scene. Make sure you click on world before clicking on this chain button, but yeah. So now we have a coin in our scene. We can click Ctrl D to duplicate it a few times and spread them around our scene. But when I click play, you'll notice that they don't actually do anything when I run into them. And that's because we haven't defined any behavior for them yet. So to do that, just like before with the player, we're going to want to add a script to our coin. And it's fine just being called coin GD, and click create. And inside of our coin script, we're going to want to first click out of it, and then click back on area 2D, and then in the inspector you'll notice to the right there's a tab called node, and inside when clicking node under signals, you'll find a bunch of signals that this that the area 2D has. So a signal is basically a function that's called whenever one of these events occurs. And the event we want to keep track of is when a body enters our area 2D. So under signals area 2D, double click on body entered, and connect to the script on the coin, and just click connect. And then now we have a function here called on coin body entered body, and we know that it's receiving or that it's connected to the signal because of this green arrow. Yeah, that it's this function is called when the body entered signal is triggered. So if we just do a test print here, ASD, and kind of run our world again, go back to the world tab and click run, we'll see that whenever we run into a coin, ASD is printed out into the console. And that's good. That means that our collisions are working and that the coin is detecting a body entering. And when your projects get large, it might be tedious to keep switching tabs and pressing this play scene button. So to set a main scene that runs on default, including when you export the game as an executable, you can click on this play button, and then no main scene has been defined, select one, and you can just click select. And for our main scene, we're just going to want to select world.tscn, and that'll just define world as our main scene. And now that we have collisions working between the player and the coin, we're going to want to add something that lets the player collect the coin. So to do that, we're going to add a function within the player script, and that's just going to be func collect coin. And it's not going to do anything yet because first we're going to want to create a variable and call it coins, and by default it's going to be 0 because the player starts off with 0 coins. And inside of collect coin, we're just going to want to increment coins by 1. And yeah, so every time this function is called, coins just gets 1 added to it. And for testing, we can, inside of the physics process, we can just print coins. And inside of coin, we're not actually calling the collect coin yet. So inside of this function, we're just going to want to do body dot collect coin, and click run. And then you see every time we hit a coin, this number increases. But one thing that we want to be aware of is that on coin entered body, this body could be anybody, not just the player. So let's say it could also be the static body that the floor is. So if the coin were to come in contact with the floor, then the coin would try to call the collect coin function on the floor, and that would cause our program to crash because collect coin is not defined for the floor like it is defined for the player. So what we're going to want to do to make sure that the coin only triggers this action on bodies that are able to collect the coin is to add a check that checks if body dot has method, and then in here just the name of the function collect coin, Then we're going to want to do body.collectCoin, and then as you noticed before, when we hit the coin didn't actually disappear. So we're going to want to do QFree2 to kind of destroy this coin so that it can't be collected more than once, so no infinite money glitches. And we can delete the rest of this because this is all we need for our coin class. And now running in the world, we can see that start off with 0 coins. When we hit one, we get a coin, but it disappears from the world. And when you actually export this game, the console won't be available to the players, so we're going to want another way to kind of convey the amount of coins they have other than just console output. So to do that, we can delete our temporary test console output for coins, and then inside a player we're going to want to add some kind of HUD, some kind of UI to let the player know that they have collected 1, 2, or 3 coins. So to do that, we're going to add a node called canvas layer. And this canvas layer, we're going to add a child to it, and the child is going to be a label. And it's going to seem blank, but if you go to inspector on the label, you can just type in some random words so that you know where it is. And let's see how this fits in general on our game so far. It's kind of tiny, so we know we're going to want to have it a bit larger, but before that we're going to want to set a custom font that kind of more fits our pixely aesthetic. So to do that, in our label under control there should be a tab called custom fonts. Click check on the font, and in empty, new dynamic font, and click on the dynamic font, and inside of here there should be a tab called font and font data. Inside of the assets folder we downloaded at the beginning, there should be a file called m3x6.ttf. This is a font file, and we just drag it into font data, and now we have a pixel art kind of font. So with this font now, we can see it's kind of hugging the edge of the so we're going to want to drag it a bit outwards. Just in general, if you zoom out a bit, you might be able to see this faint purple line, and these purple lines along with this sort of turquoise line and this magenta line serve to kind of show what your viewport's going to look like when the game actually runs with respect to UI elements. So when this label was here before, it was kind of hugging the edge of the screen, so we're going to want to add a bit of space between the edge of the screen and our label. And as we noted before, the text was kind of small, so also inside of this under label control custom fonts font, there's settings, and inside of settings we can set size to 64. 64 might be a bit large. Let's find out. Nope, it's perfect. So yeah, set it to 64, and instead of this sample text we have, we can just type in points and then colon 0, or I guess coins 0. And then now with coin 0, running the game, you'll notice that nothing happens because we haven't defined that yet. And in order to do that, we're just going to be kind of replacing the text that appears on the label. So to do that, we go to our collect coin function, and right after we increment the coins, we're going to want to get the label. So a $ and canvas layer / label, and then after that we click dot text to get the text attribute from this node, and then we set it to coins, and then colon space, and then plus str to cast our coins to a string. So coins plus str coins, and then now when running the game, uh, anytime we collect a coin, the counter should increment. And yeah, that's pretty much it for our basic platformer. Thanks for watching, and see ya.